Hello, this video is on compound inequalities. Please make sure you fill in your note sheet as you watch. I will be checking these the next time we have class. So a compound inequality is when two simple inequalities are combined into one statement by the words and or. So there are two types of compound inequalities. There's the and compound inequality and the or compound inequality. Now the intersection, or an intersection, is the overlapping region when graphing solutions of a compound inequality involving and. So when you graph an and compound inequality, you should get an intersection. When you graph an or compound inequality, you'll get a union. That's when the combined regions when graphing solutions of the compound inequality for an or. So you'll get two different graphs depending on the type of compound inequality. So when using and, you're going to have one graph. So when we have an and compound inequality, we talked about having an intersection. This inequality right here, -4 is less than x is less than or equal to 2, is an and compound inequality. I can tell that because the x in the middle right there is squished between two inequalities there. It's an and compound inequality. So x has to be greater than -4. That should be an open dot. Greater than -4, and it has to be less than or equal to 2. So that one should be shaded in because it's less than or equal to. And then it's an intersection, which means that it combines into one combined graph like that. When you're using an or, you're going to have one graph go to one end and another graph go to the other end. Or in other words, your graphs do not cross. And we call that a union. So an example of an or compound inequality is given down here. The nice thing with or compound inequalities is they have the word or in them. So you know that's what they are. So in this case, x has to be less than or equal to 1. So I'll put a closed dot there. Less than or equal to would be pointing to the left, or x has to be greater than or equal to 4. So again, my dot should be shaded in, and I have to be greater than or equal to 4. So notice my two graphs go in opposite directions. We call that a union. So here are some steps that might be helpful when you're solving compound inequalities. Step 1 is to split the compound inequality into two different inequalities if the variable's in the middle of it, which means it's an and. And or compound inequality is already split into two equations, which means you can skip step 1. Step 2 says solve and graph each equation. And actually, that should be inequality. Solve and graph each inequality. Because we're working with inequalities, not equations. Remember to flip the sign if you multiply or divide by a negative number. That still holds true here, as with regular inequalities. All right, we're going to jump right into some examples. So when I look at this first one, 4 is less than or equal to x plus 2, which is less than or equal to 8. I know this is an and compound inequality because the x is squished between two inequality symbols. That means it's an and. So what we want to do is split our original inequality into two. So for the first one, I'm going to ignore the less than or equal to 8, and I'm just going to work with the left side. So I'll have 4 is less than or equal to x plus 2. That's my first inequality. And for the second one, I'm going to ignore the 4 on the left side and just work with what's on the middle and right. So I'll have x plus 2 is less than or equal to 8. So that's how I take one inequality and split it into two, and then I'll solve each independently. So this one I'd have to subtract 2. I get 2 is less than or equal to x. I also need to solve this one. Subtract 2, I get x is less than or equal to 6. From here, there's two different ways you can write your answer. So I could write, and actually when you guys read this one, it says 2 is less than or equal to x. If you prefer x on the other side, then I would have to flip it. So it would be x is greater than or equal to 2. Those two are equivalent. So one way to write the answer, x is greater than or equal to 2, and, since it's an and, x is less than or equal to 6. If you like to squish it into one compound inequality, I could write it as 2 is less than or equal to x is less than or equal to 6. So these two are equivalent, just depends on how you prefer to write them. When I graph them, I know that x has to be greater than or equal to 2, solid dot, and x has to be less than or equal to 6, also solid then, and I know that my graph should make an intersection, it's an and, so they should be combined for one graph. Okay, so this example is another and. Again, x is in the middle between two inequalities, so I need to split them. I like to draw my arrows to remind myself. So I have negative 5 is less than or equal to 2x plus 3. And 2x plus 3 is less than 9. Solve it like a regular inequality, so I'd subtract 3. And I have negative 8 is less than or equal to 2x. Sorry, it's a little sloppy, guys. And then divide by 2. So then I'd have negative 4 is less than or equal to x. That's one solution. Solve my other one, subtract 3. I have 2x is less than 6. Divide by 2. And I have x is less than 3. So again, two ways to write my solutions. I can write it as negative 4 is less than or equal to x and less than 3. That's one way. If you like to have them split, I could say x is greater than or equal to negative 4 and x is less than 3. When I'm going to graph it, x has to be greater than or equal to negative 4. Again, that should be shaded in. 3 should be open. And then I will connect those. Okay, we're going to look at our first OR inequality. We know it's an OR because it's got the word OR in it. It's already split for us, so we just need to solve each. I'm going to add 4 here on both sides. I get a is greater than 5. Add 4 here. And I get a is less than 1, so I know a is greater than 5 or a is less than 1. Only way to write our final answer here. I'm going to go ahead and draw it. So a has to be greater than 5. That's going to be open. Greater than 5 would go that way. Or a has to be less than 1. Should also be an open dot. Less than 1. Remember, this one should look like a union, which means we have two different graphs here because they go in opposite directions since it's an OR. Okay, again, this is another OR. We know because the OR is in there. So I'm going to solve each. I've got to divide by 2. I get x is less than or equal to 3. Divide my next one by 3. And I get x is greater than 4. So I get x is less than or equal to 3 or x is greater than 4. So less than or equal to 3 is going to be a shaded in dot. Less than or equal to, or x is greater than 4. Okay, now in these examples, you're going to practice writing the compound inequality that's shown there. So this one, I can see that the graph are the red lines on there, and they point in two different directions. You can kind of see underneath, one's going that way, and one's going that way. So since they go in two different directions and they don't overlap, this is an OR, compound inequality. So what I'm going to do is I'm going to write an inequality for this first one, which would be x, and it's going to be less than or equal to, it's shaded in, negative 1. And then I'm going to write one for this one, or x, and it's going to be shaded in again, so greater than or equal to 7. Final answer for what's shown there. Bottom one is an and. It's only one graph. So I have to look at where x falls between. So I'm going to look at kind of my endpoints here. I have one endpoint here and one here. So I can see x has to be greater than or equal to 0. It's pointing in that way. And I can see that the biggest is 6. X has to be less than 6. That's one way you can write your answer. If you like to squeeze it in one, I'd have 0 is less than or equal to x is less than 6. Those two are equivalent. Two different ways to write them. And last thing is to practice some word problems. So the first one says, sloths are famous for sleeping. On average, they sleep between 15 and 18 hours per day. Write a compound inequality to represent this. So let's say we do x is hours slept. So it's good to pick your variable right away. And if they're going to sleep between 15 and 18 hours per day, that means it could be 15, 16, 17, 18, or any decimals in there. So this one should be an and compound inequality. So they have to sleep between 15, so x is greater than or equal to 15, and less than or equal to 18, since it's between 15 and 18. X is less than or equal to 18. That's one way to write the inequality if you like to put it into 1. I know 15 has to be less than or equal to x, which is less than or equal to 18. So if you like this second version here, that one's like showing in one step that the sloths, the hours slept x, is between 15 and 18 hours. In 2, we're looking at a recipe for cookies. It has instructions to bake them for 16 to 20 minutes. Okay, so in this case, x would be minutes that they're baking. And it has to be between 16 and 20. So anywhere from 16 to 20 minutes. And you can kind of imagine that 16 to 20 in a number line. It has to be between 16 and 20. So they have to cook at least 16 minutes or more. And at most, they can cook up to 20. That's one way to show it. So at least 16 minutes, but no more than 20. If you like to condense it, you can show it as 16 is less than or equal to x, less than or equal to 20. So my cookies need to be baked between 16 and 20 minutes. Okay, 2 more. So there's some lab chemicals that are very sensitive to heat. Alarms can be installed to alert staff if the temperatures rise above 72 degrees or falls below 60 degrees. Write a compound inequality to represent this. And this is something that really can be set up for things that maybe become explosive if they get too hot or too cold and things like that. So in this case, it's important that the alarms are set. And here, it's going to go off if it's above 72 degrees, so 72 degrees or higher, or if it's 60 degrees or lower. So if you imagine this on a number line, and you have 60 and 72, it would be if it's higher than 72 or lower than 60. So in this case, I'm looking at an or compound inequality. The alarms go off if it's greater than 72 or if it's less than 60. That's my compound inequality. For our next one, public transportation is a great affordable way to get around. Discounted tickets are offered for children under 6 years of age or over the age of 55. Write a compound inequality to represent the ages that qualify for the discounted tickets. I kind of gave a hint here. That word or is a hint that this is going to be an or compound inequality. So we get a discount if kids, so let's say x is age, if the age is less than 6, or if you're over the age of 55, you will get the discount. Thanks for watching. If you have any questions, please make a note or ask me in class. Thanks.